Alright, so I had a customer that needed this pulley made for a grooved belt. And to get those cuts in there, there's several different ways you could go about doing it. I didn't have a really good way to do it myself, so I was looking at the options to get it done. One way to go is if I had a fourth axis, a rotary fourth axis, which I don't. I could get a form cutter and cut the teeth with that. And that would be one of the best ways to go to get this machined. But to go that route, you would need to get a form cutter made. And you'd have to have a CNC fourth axis, which I don't have. So I was looking at the options to get it sourced, and what I came up with was to send it to a place that does wire EDM, because that's a pretty accurate way to cut intricate shapes. Another way to do it would be to send it to a place that does water jet cutting. Water jet cutting, that's not as accurate, but for this, since it's mainly used for indexing and the customer said that the accuracy doesn't need to be too awfully tight, that could have been another option. So I sent it to a place that did wire EDM and had them cut out the profile. And they charged me quite a bit to do that work. So I was kind of hesitant as to send it to them or find another way to get it done. But I went ahead and sent them the order and sent them the part. And when I got the part back, it was kind of a bummer. I was like, well, this didn't turn out the way that I wanted. Because what they did was they cut out half of the profile and then flipped it 180 and cut out the other half of the profile. And the outside diameter on that profile needed to be 9.147, and that'll bring in the right circumference of the part to make sure that all the teeth fit, and also make sure that the shape and profile of the teeth are correct. But when they did it, their outside diameter was too large, and it came in anywhere from 9.14, which is actually a little bit undersized, all the way up to 9.167. And not only did they have too large of a diameter on their cuts and didn't compensate for that or recut it, those also weren't centered on each other. So they were shifted slightly from each other, okay? Now at first, I didn't realize how big of an issue this was going to be. So I had my customer bring a belt that's supposed to fit this, so we could double check to make sure it would work before they picked it up. And when I was laying on the belt, I noticed that after a little while, the belt just jumped out of the grooves and looked like it was off of like half a tooth, which would be, completely bad, right? And at first I was sweating a little bit because I was like, this part cost me a lot of money and I didn't have a whole lot of room on it due to the cost of sending the work out to get done. And it looked scrap to me. I wasn't sure that I'd be able to rework it and make it a viable part. But I figured I'll give it a shot anyways. I'll try and save this part, right? So what I did was I went into my SolidWorks, and the only way that I could work on this and cut these teeth is if those bottoms of the teeth were full radiuses, okay, so I could use an end mill. And the way that the shape is actually designed is with a little bit of a flat in the bottom. That's why using a form cutter or cutting it out with a wire or, you know, something like that would be an ideal way to go. But for me to rework it, I rounded off those corners in SolidWorks. And I used a 1/16 end mill, a pretty long 1/16 end mill, because that's a 1/2 inch thick piece of material. So yeah, let's do the math on that, right? That's a little over 8 times diameter. But luckily I had an end mill that was, you know, made for doing this. It was a long reach 1/16 end mill that just had the cutting flutes at the end. So it was, you know, fairly rigid on that reduced shank. And I loaded up the part in my mill, aligned the teeth with a gauge pin, and went ahead and ran it. Now the big question to me was if these teeth were misaligned to the point where it couldn't be remachined. You know, I'd wind up cutting out some teeth and just having a bad sprocket. But luckily it was just a slight alignment issue and a diameter issue that caused this problem. And after I got it machined halfway down, I took some pictures of it so you can see the difference in the part and what was causing the issue. And as you work around, you can see where it was shifted a little bit. You can see how it cut a little bit more in some areas than other areas on the diameter of the part. And when it was halfway down, I also checked the fit of the belt just to make sure that we were solving the issue. And I just ran the rest of it, and it came out all right and fixed the issue. And after I did this, I was like, you know, while it took quite a bit of time to machine the profile of these teeth, doing it this way with the little end mill, just working my way around, I probably should have done this in the first place, because part came out good and I could have saved myself a lot of money and grief from sourcing this part. Now I will say that an even better method for me to do on machining this would have been to have a fixture plate that I bolted this to before I machined the teeth, because I did have a little bit of distortion in the part from clamping onto it. And if I had a fixture plate, I wouldn't really have any distortion in the part on the diameter. But this worked okay, and, you know, fixed the part and made it all good. So, hey, I call that a win in my situation, right? Well, thanks for watching. Have a good one and take it easy.